Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, Official Guide to the Revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 239. Please start with page number 239, and today is our lesson number 337. That problem that you see there on page number 239 is the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single problem from this book. If you're interested in watching the original solution at the much slower pace and far more detail, you will find the original solution on day number 123 and 124. We are dealing with parabola. A parabola with a vertex of 0, 0, a parabola that is sitting at the origin, sitting right here at the origin, has the equation that looks like this. Y equals to x squared. So here's our x and here's our y. So when x is 0, y equals x squared is 0. Y is equal to x squared. When x is 0, y is 0. When x is positive 1, let's do it in sequence let's do it in proper order so that we can follow it easily. Negative 1, 0, 1 and 2. When x is 0, y is 0, right here. When x is positive 1, y is going to be 1. Y is going to be, when x is positive 1 or negative 1, whether it's positive 1 or negative 1, when we square positive 1 or when we square negative 1, y turns out to be 1. So when x is 1, y is 1. And when x is negative 1, y is also 1. Similarly, when x is 2, y is going to be 4. When x is negative 2, y is going to be 4 also, because y equals to positive or negative 2 squared is going to be 4. So when x is 2, y is 4. 1, 2, 3, 4. When x is negative 2, y is again 4. So there is our parabola. The question is, what happens to it? The question is, what happens to it if we were to pick it up and begin to shift it? Shift it left or right or up or down. This part is very straightforward. This parabola is simple, is stabilized, is well behaved, is sitting nicely at the vertex, is sitting nicely at the origin. Now let's pick it up and begin shifting it. Let's see what happens. So we're going to shift it to the right by 1 unit. We're going to shift it to the right by 1 unit. Let's do that, shall we? Shifting it to the right by 1 unit simply means that whatever values of y that were there before, those same values of y will take place 1 unit later, because we are picking it up and shifting it to the right. So this vertex, instead of being at 0, 1, is going to end up here. This point here, which was 1, 1, will end up here. This one was at 2, 4. Instead of 2, 4, it's going to end up at 3, 4. This one was, when x was negative 2, the y was 4. Now x is going to be 4, or y is going to be 4, and x is negative 1. This point, instead of being here, will end up here. Entire thing is shifted by 1 unit, as we said, and it looks like this. Let's put it in a different color so we can see it easily. The question is, what is the equation of this new parabola? A parabola that has been shifted to the right by 1 unit. How do we write the equation of it? Somehow we have to have the same values as before. The values of y cannot change. When y still has to work out to be, as by looking at this parabola, we can see that now y has to be 0 when x is 1. When x is 1, y has to be 0 before when we plugged in 1 for x, y turned out to be 1. We had this equation. Before we had this equation, y equals to x squared. Now if we put in 1 in here, y is going to be 1. But we can clearly see that when x is 1, y has to be 0. What do we need to do to this equation so that y turns out to be 0 when x is 1, which we can clearly see is the case here. Y is 0 when x is 1. Y is 1 when x is 2. If we were to put a 2 here, we'll end up with 4. We can't have 4. Y needs to be 1 when x is 2. What do we need to do to this equation to make this happen? In other words, what sort of adjustment do we need to do? The adjustment that we need to do is to understand, first of all, and realize that in the new parabola that we just drew, by the virtue of shifting it to the right by 1 unit, what we have done here is that this new parabola, the x-coordinate of every point in this new parabola is 1 more than before. X-coordinate of each point on the new parabola is 1 more than before. Because it is 1 more than before, because the x-coordinate of every single point is 1 more than before, we need to compensate for that. We're going to compensate it by taking 1 away from the x-coordinate. Whatever the x-coordinate of a point happens to be, we're just going to subtract 1 from it to compensate for the fact that it has been shifted to the right. And if we do that, we'll be fine. Watch what happens. So instead of our equation being x squared, now whatever the x-coordinate happens to be, we're going to subtract 1 from it. So we'll have, instead of when x is equal to 1, we'll have 1 minus 1 squared. 1 minus 1 squared is 0. What do you know? When x is 1, y is 0. Similarly, when x is 2, is x minus 1. 2 minus 1 is 1. 1 squared is 1. Oh, what do you know? When x is 2, y is 1. Here we can see when x is minus 1, we can see that when x is minus 1, y happens to be 4. Before, when x was minus 1, y was only 1. Now, when x is minus 1, y happens to be 4, which we'll see here. When x is minus 1, it's minus 1 squared, minus 1 and another minus will end up with negative 2. Negative is 2 squared will give us 4. When x is negative 1, y is 4. You see? Now we get the proper y coordinates of every point on this red one, the new parabola, because we have compensated for the fact that the x-coordinate was 1 more than before. Since the x-coordinate of every point is 1 more than before, we need to take 1 away from it. That's the part that is counterintuitive to most students. Most students end up making a mistake here. They just assume that because you're shifting it to the right, the x-coordinate of x has gone up by 1 unit. They are correct. You're absolutely correct. The x-coordinate of every point has gone up by 1, which is precisely why we need to subtract 1 from the x-coordinate. Which is precisely why we need to subtract it. It's counterintuitive. Because it is increasing by 1, we have to subtract 1 from it. And that's how we make the adjustment. So the equation of this new parabola is x minus 1 squared. Now instead of I need the room here, so I'm going to erase it now. Now instead of Instead of 1 unit, had we shifted it to the right, shift to the right by 5 units, had we shifted it to the right by 5 units, it would have been x minus 5 squared. Had we shifted it to the, let me change the marker, this marker that I picked up is not as good. Had we shifted it to the right, by 7 units, had we shifted it to the right by 7 units, it would have been x minus 7. Had we picked it up and shifted it to the right by half a unit, this would have been x minus half. And generally we write this as, if we shift it to the right by a units, it will be x minus a squared. Similarly, if we were to shift it to the left by 1 unit. Now what sort of adjustment do we need to make? Well, exact opposite logic will apply. Because we are shifting it to the left here, listen very carefully, if I were to pick up the parabola and shift it to the left 1 unit, then obviously by shifting it to the left on the x-axis, the x-coordinate of every single point is going to be 1 less than before. X-coordinate of every single point is going to be 1 less than before. We can't have that. X-coordinate has to be the same as before in order for the values of y to work out to be the same. Well, how do we do that? What sort of adjustment do we make? Every x-coordinate of every point is 1. Every x-coordinate of every single point on this graph, when we shift it to the left, is going to be 1 point deficient, 1 unit deficient rather. Well, if it's 1 unit deficient, we just give 1 to it. This is our compensation. By adding 1 to the x-coordinate of every single point, we make the adjustment for the fact that it has shifted to the left by 1 unit. Now, if we were to shift it to the left by 5 units, it would have been x plus 5. And if we shift it to the left by a units, it will be x plus a. That's it. That's all there is. That's all you need to understand. The next thing we're going to do is, we're going to ask ourselves what happens when we shift it up and down the axis. Up and down the axis. Let's do that. Now we're going to start our story from scratch, and we're going to take our parabola and we're going to shift it up and down. Let's shift it down by 4 units. Okay, let's shift it down by 4 units. So here's our original parabola. It looks like this: 0, 0, 1, 1, 2, 4. This is 1, 2, 3, 4. 1, 2, 3, 4. So when x is 2, y is 4. When x is negative 2, y is 4. When x is 1, y is 1. When x is negative 1, y is 1. Now what are we going to do? We're going to pick it up. We're going to pick it up and shift it down. Shift it down by 4 units. Watch what happens. So here's our x and here's our y. Before, when x was 0, y was 0. When x was 1, y was 1. When x was 2, y was 4. When x was negative 1, y was 1. When x was negative 2, y was 4. Now, this is the old one. The new y, the new value of y coordinate, is going to be what? What do you think it's going to be? Well, instead of sitting at 0, 0, it's going to sit 1, 2, 3, 4 units below here. It is going to sit as 0, negative 4. The vertex of this new parabola is no longer going to be 0, 0, it's going to be 0 and negative 4. So before, when x was 0, y was 0, now y is going to be negative 4. Before, when x was 1, y was 1, now it is going to be 1 minus 4. 1 minus 4 is negative 3. When x is 1, y is going to be negative 3, right here. Before, when x was 2, y was 4. Now it is going to be 4 minus 4. When x is 2, y is going to be 0. The value of the y is going to be 4 less than before at every single point. The y coordinate, rather what I meant to say is, the y coordinate of every single point is the same parabola, same relationship. The shape of the curve has not changed. It's the same relationship between x and y, except the y coordinate, listen very carefully, the y coordinate of every single point is going to be 4 less than before, because we have pulled it down by 4 units. Before, when x was negative 1, y was 1, now it is going to be, now it's going to be 1 minus the 4, it's going to be negative 3. When x is 1, y is going to be negative 3. Before, when x was negative 2, y was 4, now it is going to be 4 minus 4, it's going to be 0. And here's our new parabola. It's the same guy as before, it just has been shifted down by 4 units. Again, I'm going to put it in a different color. So what we find is that the shift along the y-axis, up and down shift along the y-axis, actually is very easy to understand because it is not counterintuitive. The shift along the x-axis is counterintuitive. One more time, shifts along the x-axis is counterintuitive because when you shift it to the right, we have to subtract that many units from the x. If you shift it to the right by 5 units, it has to be x minus 5. When you shift it to the left, it has to be x plus 5. Along the y-axis, it's not counterintuitive. If you go up by 7 units, the value of the y is going to go up by 7 units. If you go down by 3 units, the value of the y coordinate is going to go down by 3 units. So the equation of this guy is very easy to figure it out. So here, why do we have a negative 4 here? Because before, when x was 0, y was 0. Instead of a 0, before, when x was 0, y was 0, now it's going to be 0 minus 4. As you can see, whatever the values of the x was before, is just 4 less than that. So the new y is simply whatever the value of the y was before, which was x squared. The value of the y was equal to x squared. Now it's just 4 less than that. Voila. So if you shift it, here's our equation here, x squared minus 4. So if you shift it up, if you shift it down instead of 4 units, if we shift it down by 2 units, where can we put it? If we shift it down by 2 units, it's going to be, y is going to be x squared minus 2. X squared minus 2. If we shift it down by 12 units, it's going to be x squared minus 12. If we shift it down by 7 units, it's going to be x squared minus 7. Now what happens if we shift it up? If we shift it up by 7 units, now by shifting it up, the y coordinate of each point is going to be 7 more than before. That's all it is, which is going to be whatever the value of the y coordinate was before, which is given by x squared here. The value of the y is y equals x squared. Before it, y equaled x squared. Now if you shift it up by 7 units, it's going to be 7 more. That's all. So if you shift it up by a units, it's just going to be x squared plus a. That's all. Now we're going to combine the two together. Now we're going to lift our parabola and we're going to shift it along the x-axis and y-axis together. Let's do it together. Now that we understand the concept, we should be able to tell just by looking at it, just by visual inspection, in a matter of seconds, in a matter of 3 seconds, 5 seconds at the most, 10 seconds if you're taking too long. By visual inspection, you should be able to tell very easily, very quickly, right away, immediately, where this parabola is sitting, what has happened to it. Let's take a look at it. Here's our parabola. Y is equal to x minus 1 squared minus 4. Can you tell me what has happened to this parabola? Because it is x minus 1 tells us that it has been shifted to the right or left? To the right, exactly. For the x coordinate, it is counterintuitive. Because it is minus 1, it is shifted to the right by 1 unit. And then we have minus 4. So whatever the value of the y was before, this was the value of the y before, now it's 4 less than that, which tells us is that it has been shifted down by 4 units. That's all. Now we can plot it. It's the same parabola as before. Parabola is just a parabola. We just have to locate it at a different point. It's not located at the origin. It's located somewhere else. It is located, it's been shifted to the right 1 unit. And it's down 4 units. 1, 2, 3, 4. This parabola is sitting right here. This parabola is sitting right here. And it looks like this. There you go. There we go. It doesn't look very nice, but that's what it is. It's sitting right here. It is sitting right there. Let me redraw it. I don't like it. Let me just do it freehand. That'll be better. There you go. This coordinate of this guy is -1, sorry, 1 and -4. It has been shifted. It has been shifted. It has been shifted 1 unit to the right. It has been shifted 1 unit to the right, and 4 units. This is -4. 4 units down. And this line that we just plotted here has the equation of this line is that x is equal to, along this dotted line, no matter where you are in the dotted line, what are the x coordinate of this dotted line? The x coordinate of the dotted line is 1. The x coordinate of entire line is 1. So this x equals to 1 is the equation of this dotted line, and this dotted line is called the line of symmetry. The very last thing we need to understand is that this equation that you see on the blackboard, by the way, this graph that we just plotted, is the exact same graph that you see in the book there. Just give me 1 second here, I keep going back and forth my eyes. Let me just analyze it here. There we go. This graph that we see here is the exact same graph that you see on the book there on page number 239. Turn to it, page 239, you will see the graph there is the same one. But they tell us that the equation of this one, they tell us that the equation of this guy is y equals to x squared minus 2x minus 3. X squared minus 2x minus 3. They tell us that the equation of this guy is this one. We are saying that the equation is this one. This equation looks nothing like that one to me. Let's see what we can do, shall we? We can't leave it like this. We have to do something with it to write it in the proper form here. So we open the parenthesis and we find x squared is a minus b whole squared is what it is, which is equal to a squared minus 2ab plus b squared. Our a is x and our b is -1. So it's 2 times x plus 1 minus 4. And we get x squared minus 2x, a plus 1 and a -4 is going to give us -3. Voila. There we go. Now the last question that we have to understand is, the question is, if we are given this equation, if we are given the equation of a parabola in this form, if we are given the equation of this parabola of this equation in this form, how do we go from here? How do we figure out what the shape of the parabola is by looking at this equation? How do we go from here to here? How do we find out? How do we find out where the vertex of the parabola is and where it cuts x-axis just by looking at the equation y equals to x squared minus 2x minus 3. Now that is a lesson in itself. And to answer this question, one more time I'm going to read the question to you. If we were given nothing else at all, if we're simply given this equation here, first of all we have to be able to recognize that this is an equation of a parabola, which is a big challenge in itself for a lot of people. The next question is, even if you did recognize, even if you did realize that it's an equation of a parabola, the question is, how do we find out where it is sitting? How do we find out where the vertex of this parabola is? We know now the vertex is right there. Next question is, where does it cut the x-axis? It's cutting the x-axis here. What are the coordinates of these points? In order for us to be able to draw the shape of the parabola, simply knowing the vertex is not enough. Simply knowing the vertex is not enough. We have to know where it cuts the x-axis. For example, here's the situation. Maybe it's sitting here. Maybe it is sitting here. But simply knowing that it's sitting here, simply knowing that this is the vertex, we can't really tell whether the parabola that we're looking at is this parabola, or whether the parabola that we're looking at is this parabola, or whether the parabola that we're looking at is this parabola. we cannot tell simply by knowing the vertex, we cannot tell how fat or skinny the parabola is. In order for us to know how fat or skinny it is, we have to know where it cuts the x-axis. How do we find that out from here? How do we find out where the vertex of this parabola is and where it cuts the x-axis just by looking at this equation? The answer to that question, as I said, is the lesson in itself, which we'll do tomorrow, and the answer lies in the concept called, I need the room somewhere. I'm making a big fuss about it for a reason. Where can we put it? Let's put it right here. It lies in the concept called factorization. If you're not good at that concept, if you're not very familiar with this concept, if you're shaking on it, if you're not very good at factorization, because you have to be able to do this thing within seconds, 30 seconds, 1 minute at the top, 1 minute tops. You have to be able to factorize this equation very quickly to be able to figure out where it cuts the x-axis, to be able to figure out where the vertex is. That process should not take more than a minute, minute and a half, 2 minutes if you're slow. But in order to achieve that kind of speed, you have to familiarize yourself with this concept, thoroughly familiarize with yourself. So if you're not familiar with the concept of factorization, if you're not very good at factorizing, what I want you to do is, this is your homework before you watch tomorrow's video. What I want you to do is, obviously you are at YouTube, put in the search bar there, put down factorization along with my name, and you will see several videos that we did before dealing with this concept of factorization. Watch as many videos as you can, solve as many problems that you can find on my channel dealing with the concept of factorization, and that's what we're going to have to do tomorrow. We're going to have to factorize this equation to answer this question. Where does it lie? Where is the vertex? And where does it cut the x-axis? We have to answer those two questions before we can figure out the shape of the parabola. We'll do that tomorrow, okay? Bye now.